is our homework. Here's our homework. Here's the notes for today. What side do we start taking our notes on? Left side, good. We're classifying numbers. What is tonight's homework? It is, and what problems are they? 22 to 34. It's the last section of the number set. Same bit.ly as before. We're classifying numbers. Today is the 12th. Please put that into your notes. Yes, link in description. Make sure you click the bell icon. Subscribe to my YouTube, etc., etc. Okay, I will post the lessons again, and as always, they go onto my YouTube channel. I don't use it for anything else, but literally my account's connected, so that's what I use. If you want to rewatch the notes later because you need some more help, that's where it is. So we're going to get started. We're talking about different number classifications. We're talking about the two main ones. Our first is rational numbers, okay? So rational numbers. These are numbers that can be written as a fraction, including positive and negative whole numbers. I want you to draw attention to the negative part because my first two classes were quite forgetful of that part. So it can be positive and negative whole numbers. We all know what a whole number is? Like 1, 2, 3, 4, 5, negative 1, 2, negative 2, negative 3, negative 4, negative 5. Just not a fraction or a decimal. Our next kind of rational number is a fraction, but I have a whole number or integer in the numerator and in the denominator. So like 2/5, 3/7, 99 100ths. Those are all rational numbers. They're fractions. Next is a terminating decimal. Do we know what terminating means?
Doesn't repeat.
What do you mean doesn't repeat?
Doesn't have the line thing.
Okay, so that's repeating. But terminating is a little bit different. What does the word terminate mean? Yes, that's like Arnold Schwarzenegger. But what does terminate mean? Kind of. Terminate means to end. So these decimals end. They don't go on forever and they don't repeat. So a terminating decimal is like 0.75 or 0.4 or 1.596. So it's a decimal that has an end. Next is my repeating decimals, which Sam said is the kind that has the bar over it. So that's like 0.3333333333 on forever. That's a rational number. Or 0.66666666666667 when it goes on forever. 2/3. I said enough sixes. Calm down. That's a repeating decimal. Or if I have 0.12345, 12345, 12345 on forever, those are all repeating decimals. Does that make sense? And if you see a bar over it, the bar goes over however many numbers repeat forever, okay? Now we have irrational numbers. So we have rational and irrational numbers. Our irrational numbers, this is a number with a decimal that does not terminate or repeat. So these are the ones that go on forever. So they have the ... or the ellipses, or they just go on forever. They don't end and they don't repeat. It's just a bunch of numbers, a string of numbers.
Notes in pen.
Yeah, you can take your notes in pen. Just homework is in pencil. Okay, a number with a decimal that does not terminate or repeat is an irrational number. And I'll put that back up in a minute, but I have a few other things to say about that. It cannot be written as a fraction with integers, and it's a radical that cannot be simplified. So, it's a number with a decimal that does not repeat. So that's like 0.321 ... goes on forever. If it can't be written as a fraction with integers, maybe it has pi over 3, because what is pi? 3.14, but we've rounded it to that, right? It's 3.1415 ... on forever, right? We don't know where pi ends. So is pi rational or irrational? Do I know where pi ends? No, so it goes on forever. It's an irrational number, okay? Or maybe a radical that cannot be simplified. So can I take the square root of 5? Do I know that? Is anything times itself 5? Not like a whole number that I can think of, right? I can approximate where it is, but I don't know its value. Or what about the square root of 93? Was that one of my numbers? No. So those are both irrational. And I can also write this. It's like, let's say the square root of 2 over 2. Do you see how the square root of 2, that's not an integer? That's an irrational number. So this number itself, the square root of 2 over 2, that's an irrational number as well. Does that make sense? Is that okay? Are you listening? Okay, do you understand the different classifications and the comparisons between rational and irrational? Okay, now I'm going to give you some numbers. We're going to work on some together. We're going to decide, are they rational or irrational, and why. Okay, ready? Because I'm going to move on. Okay. Nobody said no. So. Here are our first 5. I have the square root of 5. What kind of number is that? Is it rational or irrational? Can I take the square root of 5? Can I take the square? Is it a perfect square? No, so it's irrational. Okay, what if that was the square root of, let's say, 4? It's what? Why? Because the square root of 4 is 2. Perfect. What about 1,323? Is it rational or irrational? Why is it rational? Yeah, it's a whole number. It doesn't go on forever. What if I changed it and put this? What kind of number is it now? It's still rational. It's just a larger number. Before it was 1,323. Now it's 1,323,567. It's still a rational number. It's just a longer rational number now. What about 3 2/3? So that one has a fraction in it, doesn't it? Yeah. What do our classifications say about fractions? Is it rational or irrational? Why is it rational? Irrational numbers can't be written as a fraction. And also this is an integer in the numerator and in the denominator. So that's how I know it's a rational number. Even if I had 2/3 as a decimal, remember that's the one we don't like to say, that you all said, ooh, it's 0.666666 on forever. Even if I wrote that as a decimal, like this, that's a rational number as well. Does that make sense? Because that's a repeating decimal. Okay, now what about 1.2782? Does it have an ellipses on the end, a dot, dot, dot? No, so it's rational because it's what kind of decimal? An ending decimal, which is called a terminating decimal. You understand what that looks like now? It's a lot of the decimals that we work with. And finally, I have pi over 2. Why is it irrational? Because the numerator isn't an integer. The numerator is an irrational number, and it wouldn't terminate if I wrote it. Is this okay? Are we okay on this? Are you ready for 4 you tries? Okay, you can do these in your group. I'm going to give you a minute or 2. Ready? Because I'm going to go to the next slide. You done copying? Okay. Okay, can you try these next 4, please? I'm going to give you a couple minutes in your groups, and then I'm going to call on you randomly with my numbers. Okay, number 6 is going to be seat number 9. Who's that? Is that anybody? No, nobody. Got lucky. 21. Do I have somebody at 21? What about 33? Is that another empty desk, or is that you? So then who's 33? Okay, Leela. Do you have an answer for me for number 6? Why is it rational? Yes. So it's negative, and the numerator and denominator are both integers, which makes it rational as my fraction. Good. Do we get that one? Okay. Number 7 is seat 10. Is that one you, April? What is number 7? Because the decimal does not end. Do we agree with her? I do. Number 8 is going to be seat 24. Do I have someone there? You said rational? Why? Yep, because that bar tells me it repeats. So it's 0.25726, 25726, 25726 on forever. So yes, number 8 is rational. And do I have a seat 32? Is that one you, Sarah? Oh, no. It's okay. Rational. Why, Nia? Yes, the square root of 64 is 8, which is an integer, so I have a whole number. We okay on these ones? Good, good. Okay, next, number 10 and 11. This one has different operations. What operation am I doing for both of these problems? I heard one person say operation is addition. It's add, subtract, multiply, divide. Do we know what our operations are? Add, subtract, multiply, divide, and this one is adding, addition. Okay, so negative 5 plus 3 radical 2. I have addition. Can I add negative 5 plus 3 radical 2? Do you remember this from last year? It's kind of like writing this, isn't it? Can I add those two? Can I combine them? No, because one of them has the radical and the other one doesn't have anything. So they can't be combined. So this is already in its simplest form. Now, is that a rational or an irrational number?
Irrational.
Why is it irrational? Because I cannot simplify the square root of 2. Is that okay? Next, on number 11, I have negative 5 plus 2/3. And I'm adding. Can we write negative 5 as a fraction to be added to 2/3? How? I put a 1 under it. Cross multiply. That's with the equal sign. What do I want the denominator to be? So can't I go like that? What's negative 5 times 3? And what is 1 times 3? What's 1 times 3? Good. Okay, can I combine these? What's negative 15/3 plus 2/3? Hello? Negative 13/3. Is that rational or irrational? What is it? Rational or irrational? Rational, because that is a fraction with 2 integer values. One in the numerator, one in the denominator. Negative numbers are okay. Ready for 2 more you tries? Okay, on number 12, that square root of 8, you need to rewrite it using what you know about factoring, okay? 12 and 13, you do this in your group, please. Okay, number 12 is going to be desk 11. You ready? What'd you get? Irrational? Why?
Because you couldn't multiply like both of the radicals.
You can't multiply them because you're adding, so yeah, so far. Can I break down radical 8?
Yes.
Yes, how? It became 2 and 4, okay.
And then there's already a group, so you take that group out, and that becomes 4 square root of 2, then you plus, then you add the 4 and then the 2, you get 7, and then 7 square root of 2.
4 and 2.
I mean, 4, you get 7.
You're on the right track. Okay, so the 8 breaks into a 2 and a 4, and then 2 more 2s, right?
Yeah.
So 8 is how many 2s in total?
3.
Okay, so I take out a pair of 2s and leave one inside, and I'm left with this? Is that what you meant? You were on the right track, but you had your numbers mixed up a little bit. Okay, so I have 5 radical 2, and then the square root of 2 is still what? 2. No, the square root of 2 is still rational or irrational? It's still irrational. I can't simplify that any further, so now it's irrational, okay? Does that make sense? Is that okay? So you got the right answer, but your justification, do you understand why now? Okay, now for number 13, this is seat 26. Is that any of you? 26? 26? Nobody sits there? 14. What'd you get? What'd you get? Okay, shh, Josh, you said rational. And how do you know that? which is rational. Do we agree? You okay? Okay, we got a couple more. 14 and 15. What's the operation happening now? What's the operation now? Yes, before I had addition, now I have multiplication, okay? So negative 5 times 3 root 2. I can do negative 5 times 3. Those are both my coefficients. What is negative 5 times 3? And what do I do with the root 2? Just leave it. I can't do anything else with it. So what is this answer? Irrational. Fantastic. And then what about number 15? Can't I just multiply across? You see that? And what kind of number is negative 10 over 3? Rational. I have two integer values as a fraction. So that's a rational number. Does that make sense? Okay. I have 2 more you tries. 2 more. Ready for those? Okay. Too many you tries? Okay, these are different from the last 2 you tries. What is different about them? It's multiplication instead of addition. Number 16. Okay, seat 29. Do I have anyone sitting there? No. 4. Seat 4. You knew it. Okay, what'd you get?
I got 12.
So what kind of number is that?
It's an integer.
So what kind of number?
Rational.
Yes, okay, rational. Do we know how Matthew got 12 for 16? No. Okay, so here's the thing. I heard a lot of you breaking it down. It's not wrong to break this down into 3... whoops. It's not wrong to break it down the way you were trying to. Whoops, I'll undo that. So this is what a lot of us got, right? Mm-hmm. So I can multiply 3 and 2 to get 6. And then this is the square root of 4. What is the square root of 4? 2. So I have 6 times 2, which is... Now, did I have to do that? No. An easier way would have been maybe to just do, what's 8 times 2? And what's the square root of 16? And 3 times 4 is 12. So we still get a rational number. Either way, you get the right answer. But one of them takes a little bit more work. So I need you to recognize what kind of problem it is. On the last one, it was addition, so I had to break it down. On this one, it's multiplication. And when I'm multiplying radicals, I can just multiply the number inside to each other. Does that make sense? Okay. Seat 35. Do I have someone there? Is that you? Okay, what'd you get for number 17?
I got 2 over 3.
2 over what? Are we adding or multiplying or what?
So it would be 9.
So it's 2 over 9? What kind of number is that? Okay, so it's a fraction, right? 2 over 9 is a fraction. What do your notes say about the different kinds of fractions? Why? What's specific about this fraction? What kind of numbers does it have? Yeah, they're both whole numbers. They're both integer values. So yes, it's rational because I have an integer divided by an integer. Is that okay? Okay. Are we okay on these 2? Okay, I'm going to do 2 more with you now. These ones aren't you tries. After this, I got a little table for you.
You said there were 2 more. What?
These are 2 more, and then you got a table. I said I'm going to do 2 more with you, then I'm going to give you an SBAC type of question. So, 2/3. What is the operation on both of these now? What operation do I have now? Division. Good. So I have 2/3 divided by 1/3. Do I like dividing by fractions? No. What do I like to do instead? Multiply by the reciprocal. And if we forget, that means flip the fraction. So what is 2/3 times 3 over 1? 6 over 3, which simplifies to. So what kind of number do I have? Rational. Good. Now, on number 19, there's a few ways I can do this one. Do we know how to rewrite square root of 8? Because we did that quite a few times today. What is the square root of 8? 2 root 2 all over what? So what can I do? I can divide these out to 1. So I'm left with 2. What kind of number is this? Rational. Okay, so that's one way to do it. Now, if I didn't want to break down the square root of 8, because we've already done it a few times in here, so maybe you're like, oh, I remember. But if you didn't want to do that, since I have the square root on, I can rewrite this as one big square root of 8 over 2. What is 8 divided by 2? So the square root of 4 then is still 2. Do you see how I did that 2 different ways? Okay, that's how our square roots work as well. We okay on that? Okay, now I want you to make a table in your notes. We got just under 10 minutes left. Can you make this table? You're going to try it. Okay, this is very, 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 very similar to an SBAC style question. Okay. You're going to select each box in the table where the numbers from corresponding rows and columns have a rational product. What does product mean? What does product mean? Multiplication. So we're going to find if I multiply down and across, what kind of number do I get? Sure. Okay, so 4 times 4 was 16. So you told me that was rational? Okay. What about 4 times 1/3? Good, because that's 4/3. What about 4 radical 3? Good, and 4 times negative radical 3? Good. Okay, what about 1/3 times 4? Second row. And 1/3 times 1/3? That's 1/9, right? And what about 1/3 times root 3? And 1/3 times negative root 3? Good, because on both of those, radical 3 is in the numerator and it can't be simplified. What about radical 3 times 4? Radical 3 times 1/3? What about radical 3 times radical 3? Why? Because we get radical 9, which simplifies to 3. That's what I heard. Okay. What about radical 3 times negative radical 3? That one is also rational. Okay. Because root 3 times root 3 is still 3, but now it's negative 3 because I put a negative sign on it. Is that one okay? I saw some of you missing that one. And then on the bottom row, 4 times negative root 3. Negative root 3 times 1/3. Negative root 3 times root 3. Good. And negative root 3 times negative root 3. Good. Are those okay? Do you understand how to read this table? Because you will see something like this on the SBAC, and we're going to keep doing it, okay?